Hello students, let us start exercise 6.2 question number 1, and the question is integration of 9 minus 9x cube upon 4 minus x square dx. Now here we are going to first find whether the function is an odd function, yes or no. So let us assume the whole question as I. So I is equal to integration of 9 minus 9. We're going to copy the question as it is, x cube upon 4 minus x square dx. Let f bracket x, let the function x is equal to, now we are taking only the expression that is x cube upon 4 minus x square. Now here in the place of x we are substituting minus x. So the next step it is, therefore f bracket minus x. F bracket minus x. In the place of x we are writing minus x. So it will be minus x the whole cube upon 4 minus x square, which is equal to, therefore f bracket minus x is equal to minus x. The whole cube is nothing but minus x cube. Then 4 as it is, minus x the whole square is nothing but x square. So we can write this as, therefore f bracket minus x is nothing but, now students we will compare these two things. This are the RHS of f bracket minus x and the RHS of f bracket x. When we compare these two things, the only difference we can see is of minus. So we can write f bracket minus x is nothing but minus of f bracket x. So when this condition is satisfied, we can say that the given function is an odd function. So therefore f bracket x is an odd function. F bracket x is an odd function. Therefore, I is equal to 0, our final answer. In bracket, we can write the reason, since integral of a minus a f bracket x dx is equal to 0 if f bracket x is an odd function. Is an odd function. So I equal to 0 is our final answer. Next question we will start, students. Question number 2 of exercise 6.2. So it is integrals of a0 x square bracket a minus x 3 upon 2 dx. Here we are going to substitute something in the place of x. Before that, let us assume, let I is equal to the whole question, integration of a0 x square a minus x 3 upon 2 dx. So we are going to substitute here, put x is equal to a minus x. So in the place of x we are going to substitute a minus x. We don't write this step. Why we don't write this step? Because both the side we are having one variable exactly same x. So we can solve it further. So I don't want you to write this step. This is only for your understanding. I am mentioning this here. In the next step, wherever you can see x, in the place of x we are writing a minus x. Okay. So the next step will be integral of a0. In the place of x we are writing a minus x. So it is a minus x the whole square, a as it is, minus, in the place of x we are writing a minus x 3 upon 2 dx. Let us solve this further, which is equal to integral of a0. Now a minus x the whole square will expand in the formula a minus b the whole square. So we get a square minus 2ax plus x square. And here when we open the bracket, we get a minus a plus x 3 upon 2 dx. We can cancel this plus a minus a. And the next step is integral of a0, a square minus 2ax plus x square multiplied by x, as a and a got cancelled. So it is multiplied by x raised to, the index we already have, that is 3 upon 2, x raised to 3 upon 2 dx. Next step, it is integral a0 in bracket. Now we are going to multiply this x raised to 3 upon 2 with each term inside the bracket. So we get a square x raised to 3 upon 2, then minus 2ax. 3 upon 2 plus x is nothing but 5 upon 2. We use here the law of index, a raised to m into a raised to n is a raised to m plus n. Then plus x square into x raised to 3 upon 2. 2 plus 3 upon 2 is nothing but 7 upon 2 dx, which is equal to, we'll take the constant out, we'll give the integration to each term. Integral a0 x raised to 3 upon 2 minus 2a as it is out. Integral a0 x raised to 5 upon 2 plus integral a0 x raised to 7 upon 2. After every integration, we need to write here dx, dx and dx, which is equal to a square. Now let us apply the formula of integration here. So we get x raised to n plus 1 upon n plus 1, 3 upon 2 plus 1, that is 5 upon 2, upon 5 upon 2. Integral a0 will write here minus 2a. When we apply the formula, 5 upon 2 plus 1, it's 7 upon 2 upon 7 upon 2, a0 plus x raised to 9 upon 2 upon 9 upon 2, a0. Now, next step, which is equal to, when we solve it further, we get 2 upon 5. 5 upon 2, when we bring to the numerator, it is 2 upon 5. 2 upon 5 a square, in bracket a raised to 5 upon 2, minus 4 upon 7 a raised to 7 upon 2, plus 2 upon 9 a raised to 9 upon 2, which is equal to, when we solve it further using the law a raised to m into a raised to n, we are going to add the index here. So the next step we get is 2 upon 5. 2 plus 5 upon 2 is nothing but a raised to 9 upon 2. A plus a raised to 7 upon 2. 1 plus 7 upon 2 is a raised to 9 upon 2. Plus 2 upon 9, a raised to 9 upon 2 as it is. We can see that a raised to 9 upon 2 is a common factor. So what remains inside the bracket is 2 upon 5 minus 4 upon 7 plus 2 upon 9. Which is equal to a raised to 9 upon 2. When we solve this fractions, that is 2 upon 5 minus 4 upon 7 plus 2 upon 9, we get 16 upon 315. Hence the final answer is 16 upon 315 a raised to 9 upon 2. We cannot reduce this further. Our final answer. We'll continue the next sums in the next video, students. Hope you have understood. Bye.